Hello everyone, so let's start the chapter of optics with reflection. Now before we start this chapter, let's recall a few points which we have already studied in our high school. For example, we already know that in reflection, the rays, that is the incident ray and the reflected ray, and normal are coplanar. That means if we have a mirror, then the incident ray, the reflected ray, this is the incident ray, this is the reflected ray, and the normal is basically the perpendicular drawn on the mirror. All of the three lie on the same plane. The another point which we learned earlier was that in reflection the angle of incidence is equal to the angle of reflection. Angle of incidence is basically the angle which the incident ray mixed with the normal. So this is my angle of incidence, and angle of reflection is the angle which the reflected ray mixed with the normal. So this is my angle of reflection. So these two are equal. Also, you tell me, what is the minimum number of rays required? Required to determine image location. Remember that I am only asking about the image location. So what is the number of rays required to consider to determine image location? The answer is how much? 1 or 2 or 3? You tell me which is the answer. Okay. Hope you have thought over it. The answer is 2. Let's see how. Let's say this is a mirror. This is an object here, and I want to find the location of the image. So this is one ray, right? And this is another ray, right? Sorry, this is another ray. So, okay. Now, if I know both these rays, this is one ray and this is the other ray, and I know that this mirror forms a virtual image, so I can extend the reflected rays to find the location of the image. So basically I needed two rays here. This is the first one, this is the second one, to find the location of the image I. You also know that there are two types of images. One is real image and other is virtual image, right? Now what is a real image? A real image is formed when the rays or the reflected rays actually intersect. This happens when the different reflected rays converge. Then we have a real image. In other words, we can also say that a real image can be obtained on a screen. Now what is a virtual image? It's just the opposite of real image. It can't be obtained on a screen, and the rays actually don't intersect, but if the rays are extended or the reflected rays are extended, they appear to intersect. So I will write rays intersect when extended. And the reflected rays actually diverge. So that's since they are diverging, so they don't intersect. For example, in this case, this is a plane mirror. You see that the reflected rays are actually diverging. They are moving away from each other, right? So to find the location of the image, I need to extend the reflected rays here, and I have the image location here. So the rays are not actually intersecting, but if we extend the reflected rays, they appear to intersect. So these are virtual images. Okay. Now one very important point in reflection which we'll be using is, and I think you might not have studied this before, is the principle of reversibility. So let's understand what is the principle of reversibility. The principle of reversibility states that if I have an object placed in front of a mirror, and this object has an image I because of the mirror, which the image can be either real or virtual. Now this principle says that if I see it backwards, that means if my image becomes the object, then the location of the image, considering this image as the object, will be the same as the location of this object. Okay, now let's take an example so that it becomes clear. For example, again let me take up some mirror. Let's say I have placed an object here and I know the location of the images, this. Okay, now what this principle states that if I consider this as the object, okay, now if this is the object, then my image, considering this as the object, will be formed at exactly this location. This will be my image location. So that's why the word reversibility. If I reverse the position of image and object, the position of the image and object also gets reversed. Okay. Okay. Now let's study the property of reflection in case of plane mirrors. Okay, you know that a plane mirror always forms a what? Virtual image, right? This is very clear because you see that if you have a plane mirror and you have an object here, these are the two rays. These two rays are diverging from each other and the image is formed at this location. Okay, so the plane mirrors always forms a virtual image. Now how do I find the location of the image? The very basic thumb rule is that you take any of the two rays and then you extend the reflected rays from them and then you see the point of intersection. This is one thing. The other way which you can proceed is that if you have an object here, you just draw a perpendicular to the mirror, and let's say this distance is x. The image will be formed at the same distance x from the mirror. So this distance OA is equal to AI. Remember that this is the perpendicular distance. So if I say that this is my mirror and the mirror is tilted at an angle theta, and this is O, this is A, this is I. So can I write OA is equal to AI in this case? The answer is no, because as I said, we need to consider the perpendicular distance. So I can say that if this is the image, this distance is equal to this distance. But here in this case, since this is not perpendicular, I can't write OA is equal to AI. Okay. Now, another thing to consider is that if I have a plane mirror here, and if I have an object here, okay, let's say this height is h m, this height, and this height from the ground is the ground is HO. Now my question is, okay, let's say that the ground is not here, the ground is somewhere here. Now my question is, will this object be visible to me if I am somewhere here or here or here, somewhere here or here or here, will I be able to see this object through this mirror? What is your answer? Now, to understand this, a concept known as the field view of the object comes in place. This object, the rays coming from this object will be reflected like this. The rays will be reflected like this, right? Okay, this is one ray, this is other ray. So why did I take these two rays? Because these two rays are hitting the mirror at the two extreme ends of the mirror. Now, this region, this whole region, is my field view of the object. That means what? If my eye is somewhere in this region, I'll be able to see the object. Now, what happens if my eye is not in this region? If my eye is here, then there is no ray which is getting reflected from the mirror and hitting my eye. So that's why I won't be able to see the object. The extreme ray or the extreme positions where I can be so that I am able to see the object is on this line. If I am here, this ray will come and hit my eye. If I am here, this ray will come and hit my eye. So at this and this are the extreme lines where my eye can be so that I am able to see the object. This and this positions, if I am there, I won't be able to see the object. So basically these are the concepts which we need to know in case of plane mirrors. All the questions in plane mirrors can be solved using geometry, where basically we'll be using similar triangles, and in some cases we'll be using the principle of reversibility, which I had already mentioned. And the very obvious rule is that you need to always keep in mind that the angle of incidence is equal to the angle of reflection. Also, another thing which you need to keep in mind while solving questions in like reflection of plane mirrors is that if this is the plane mirror, this is my object, my image will be formed at this position, and this distance is equal to this perpendicular distance x is equal to this perpendicular distance x. These are the four things you need to keep in mind. So let's take few examples before we move on to spherical mirrors.